And that's one of the things that I don't understand. I'm going to ask, let's ask Ken. Or Emmanuel.
Mind-blowing, actually.
So we're talking about how when the light goes across from the air to the water, it changes wavelength. But it goes back to your eye, and it ends up, because it goes back through air into your eye, you see it as the same. But energy
in your eye,
it's changing too. Yeah. So we all see different colors.
But we report everything as if it's in air.
Right.
This is how we do. This is the convention.
And because there's conservation of energy,
if you did in frequency,
otherwise you would say, oh, well, now it's an ultraviolet photon because it's slowed down and shortened up.
Yep.
And that would have more energy, but it doesn't have more energy.
That's changing the energy
Slower.
of the photon.
It's just slower.
This is why when you have your C-ups, for instance,
Right.
it measures.
You go again in there.
It goes again in
As
air.
you were
In front of the
saying.
detector.
Yeah. But when you're trying to do energy balances in the ocean, you're not adding any more energy because it's conservation of energy. So it
You
doesn't.
have to do it in frequency space.
You have to do it in frequency space.
You always
Yeah.
translate back to frequency space.
Yeah.
Is that what PP models do?
NPP models? No, they count photons. But again, they count photons. They actually, for primary production, the energy does not matter. What matters is how many photons got absorbed. So they count photons.
Because you're linking
This is why power
Yeah.
is in photon units and not
Right.
And photons, it's easy.
And
Yeah.
phytoplankton don't really care if it's 440 or 460 as long as they can absorb it. It's
As long as
sufficient
it
energy.
absorbs. As long as
It absorbs it,
yeah.
then it doesn't care.
But
And if it's too much
absorbs,
energy, it gets rid of the rest of it as heat.
there's as I told, this route is heat.
It's kind of cool to think about.
Isn't
that.
it very cool?
It is. And one thing I did
It kept
when I
me up
just
for
got into
nights
this
when I was
is
a
to
student.
plot, instead of as function of wavelength, as function of frequency.
Yeah.
And it's not as simple as you think. But just think about an absorption curve from a frequency perspective. Now, interestingly enough, chemists, they do it all in frequency space.
Or in wave number space,
Which
which
is
is sort of,
frequency.
yeah.
I mean, it's 1 over
Yeah.
wavelength. So they depending on because they're focused on absorption, and absorption is a frequency phenomenon. It depends on, you go up and down these levels that are energy quantums. Scattering depends on the ratio of a wavelength to the size of the particle. So people that do scattering, they do everything in wavelength
Right.
space, because that's what matters is how big is the light compared to the particle.
Right.
So
Everything is in relative.
So different, so it's really important when you do calculation, when we do the MIG calculation, it's the wavelength in water. It's not the wavelength in air. It's
The wavelength in water, which is shortened up, right?
So you have to account for it, because what matters now is really, you're right, is the wavelength compared to the size of my particle as you propagate in water, which is different.
So
than air.
this is what kept me up when you look at the color of the light above. And then you go in the water without a mask. So there's no air. So here it's air to your eye.
Yeah, but it's still your eye.
But it's still your eye. It's
Yeah,
still
so
it's still the
your
index
eye.
of refraction of your eye.
Exactly.
Yeah. As I kept
That's
reading,
the one
like, I
before
want
the
to be able
sensor.
to see the bluing of the ocean, right, as it goes across. But you're always going back to, like, on a
always go
mask,
back
you
to
go
your
back to
eye.
air, it
Yeah.
always goes back to your eye.
And go back to the other thing you're doing, is what is your idea? It's converting photon energy into, it's sensitive to different photon energy. It's not really wavelength.
Right,
So
right,
it's sending
exactly.
So it's sending
And it's photon energy, not total energy,
It's
right?
relative
It's
to
the
the air.
it's the photon energy, not the total energy. I mean, it's sensitive to total energy, but it's not sensitive. So it's the packet of energy that it's sensitive to, the photon energy.
Blue photon registers certain strengths in each of the three.
Right, exactly. Yeah. Yeah. What? Oh, if you're colorblind. Well, you still have 3 cones, but one of them is it's overlapping too much or something, right? You just need to tune your cone. Yes. Yes.
Just so you know, if you want to
This eye will be seeing red, this will be seeing green. And then you
I think they'll be fine.
you start your secondary.
Yeah, 3. Yeah, I think that should 3, 4, 5, 6, 7.
I think because it's 250,
I mean, I actually do a lower one. Do 200. Yeah, because then you get the noisy part.
yeah, so I'll just, and I have the stuff set. I just want to double check. I finally managed to get chlorophyll, the rest of this.
So they are doing it.
They're doing it, but
They're
they
just
just
not-
haven't input it. So I found the original sheets, Rachel came, and I just put the stuff from the original sheets into the calculation. So it's around 2.7. Yes. And it was in a way down.
Yeah.
Yeah, but I never really understood it.
What optical theorem?
Oh, it's a thing about scattering it at the
0 degrees.
thing related to whatever. I always have to look it up, and then I say, but.
So is it a constant? You look it up like it's a constant?
No, it's like,
Oh,
if you really can measure the 0 degree scatter, it's related to the total scatter.
Yeah, I'll have to dig it out. We'll have a talk about it over a glass of wine.
yeah.
Before you start up, I want to take a head count of what kind of computers
Oh,
people
yeah, do
have,
it.
so whenever they're all
Do it.
back.